In this video, we're going to learn how to write net ionic equations in the context of double replacement reactions. Now, a net ionic equation is an equation that shows only what changes during a chemical reaction. It leaves out any spectator ions that don't actually participate in the reaction. So let's consider the reaction of aqueous solutions of lead-2 nitrate and potassium iodide. We're going to answer this question of what hasn't changed during the reaction and what has in just a moment, but I think we should first watch the reaction. So here we have a very well-filmed video of, this is going to be the potassium iodide solution dropping into a solution of lead-2 nitrate. And at this point, it really just looks like water and water, but both have dissolved solids in them. And here's what happens when they combine. Whoa, right? So that stuff right there, that yellow stuff, is a precipitate. It's actually in the solid phase, and there are these little solid particles, and here's some more, that are formed in this reaction. But of course, there's still a lot of water, and, well, what else? Let's think about this. Let's go back to the board here. Okay, so that solid, that yellow stuff, is the lead-2 iodide, and the potassium nitrate apparently remains dissolved. It says aqueous as a product. So let's look one step deeper into this. Let's look at the particle level. Well, if I'm going to represent the lead-2 nitrate in the aqueous solution, I'm going to show it as such. We've got these sort of randomly free-floating nitrate ions and these randomly free-floating lead ions. And I've just shown two lead-2 nitrates here. And I have twice as many potassium iodides over here. This is aqueous potassium iodide. I've got some potassiums floating around freely, and I've got some iodides floating around freely. The iodide is aqueous, the potassium is aqueous, the nitrate's aqueous, and the lead-2 is aqueous. When we have a product over here, note how the lead-2 iodide, that precipitates out, and that's our solid here. But the potassium ions and the nitrate ions, they haven't changed. They're still aqueous. So if I'm going to write what's called a full ionic equation, that is going to really represent the aqueous solutions more accurately. Instead of really saying that there's lead-2 nitrate that's aqueous, which suggests the lead and the nitrate are actually floating around together, we're going to say that there are lead-2 ions, and they are aqueous, and they are on their own. And we'll also say that there are 2 nitrate ions that are also aqueous, and they are also on their own. Want you to note that just because there's a 2 subscript here does not mean that we should have like brackets around the nitrate and say the 2 here. That doesn't make any sense, because if the brackets were there and we had a 2 here, it would suggest that like these 2 nitrates, for example, are stuck together floating around, which is absolutely not the case here. These are all independent of one another, so we put a 2 in front of the NO3 minus. Moving on, we have potassium ions that are free-floating, and we have iodide ions, which are also free-floating. But when we get to the product side, the lead, the lead-2 and the iodide have actually stuck together, and you saw it here. This is a solid, it's a precipitate, and if you allow that to sit, it will all sink to the bottom. So moving back here, the lead-2 iodide has precipitated, but the potassium cations are still aqueous. They have not changed. So you could say the same thing about the nitrate ions. So we could say these are the spectators. They don't change in the reaction. And so if we want to write the net ionic equation, what we have to do is just take the full ionic equation and cancel out the spectator ions. We see 2 nitrate anions on the left and 2 nitrate anions on the right. We cancel them out. The same thing can be done for the potassiums on the left and the right. And so when we write our net ionic equation, it's just the lead, positive 2, and 2 iodides that react together to form PbI2, and that should be a subscript for the iodide a subscript of 2. Anyway, that's all for this video. I hope it's helped. Please feel free to leave any questions or comments in the comments section below. Thanks for watching.